In this video, we're going to talk about project management networks. And so building the network, making sure we do it right, our paths from left to right and right to left, and then crashing that network. What do we need to do to shorten that network? Crashing always sounds a little bit sort of harsh, but it means shortening the network. The basic information is here. We have 7 tasks, A to G. We have the predecessors noted here. We have the duration at the basics here, and then we also have the crash costs and max days. So if I look here at A, it costs $50 to crash, and the most I can crash it is 2 days. So that's what this data is. So from there, what questions could we ask? Draw the network. How long does it take? What is the critical path? How would you shorten by 2 days at minimum cost? And how would your answer change if you couldn't shorten E at all? And then the answer, of course, that depends on whether you can shorten it at all. So let's begin. The first thing we're going to do is draw the network. As you know, when I do it, I like to start with a start node because it just makes it clearer to me. A was 3 and had no predecessors. B was 4 and had no predecessors. And C was 3 and had no predecessors. So we draw those arrows like that. D has both A and B as predecessors. So there's D, and it is 4. And E has both B and C as predecessors, so that's how we would draw it. We have the lines coming from both B and C, and then F comes out of D and is 3 days. G comes out of E and has 4 days. And then there are no more tasks, so those both go into a finish node. Again, just to uh, give you some clarity and make it clear, I like doing it in my head. So now we're going to do the paths from left to right. So anything that comes out of the start node starts at 0 and that one goes to 3. This one starts at 0. Earliest finish is then 4. The earliest start for C is 0. The earliest finish is 3. 0 plus 3 is 3. Then we look at D. In this case, D has 2 predecessors. The earliest finish time for A is 3. The earliest finish time for B is 4. So the earliest start for D is 4. D can't start till both they're finished, so we pick the longest one. So this is 8. And then we go 8 here. We carry it forward. Plus 3 is 11. Now we go down here to E. This one, B is 4. C is 3. So this is 4. Plus 4 is 8. And this is 8 plus 4. Sorry, plus 4 is 12. So now we have the earliest start and earliest finish time. We've done a pass from left to right on this. And now we start at the right. We take the largest earliest finish time and we make it the latest finish time for all of the things that go into the finish node. So here we go 12 minus 4 is 8. Notice no slack here. And we go 8 minus 4 is 4. Again, no slack. We go 12 minus 3 is 9. 1 day of slack. 9 minus 4 is 5. So 1 day of slack. 5 goes up here. 5 minus 3 is 2, so 2 days of slack. Here we go. 4, 0, no slack, and 4 minus 3 is 1 day of slack. So in order to determine the critical path, we look at the path with no, or paths with no slack. So that's this, B, E, G. So project will take 12 days, that's the longest path, and critical path is B, E, G. Now, the assignment was to shorten by 2 days, and we have BEG as our critical path. So we would go here and we look at B, which is $100 to shorten, E, which is $150 to shorten, and G, which is $250 to shorten. So what we're going to do is we're going to shorten B first. It is the cheapest option. So here we go back, shorten B first. It is the cheapest option on the critical path. You know, A is cheaper, but if you look back here, A is not on the critical path. If we shorten A, we will not shorten the project at all because the critical path will stay critical. So we're going to shorten B first. We'll just draw again. A doesn't change. It stays at 2. B goes down to 3. Sorry, it stays at 3. And C stays at 3. Remember, D comes out of both of these. D stays at 4. F stays at 3. E comes out of both B and C. The structure of the network doesn't change. The only thing that has changed is the 3 here. This is 4, goes here. G, 4. Finish. And now we do the pass from left to right. 0, 3, 0, 3 for the ones that come out of the start node, 0, 3. For D, we have 3 out of both of them, 7, 7, 10. We go down here, we have E, we have 3, 7, 7, 11. So we can look at this and see that it is in fact shorter. So let's do the backwards pass to see which one is critical. 11 minus 3 is 8. 8 minus 4 is 4. 11 minus 4 is 7. 7 minus 4 is 3. Take the 3 here, 0. 3 here, 0. So this path continues to have slack in it. But these two paths, B, E, G, critical. So it's now 11 days, so we know we've shortened it by 1. BEG is critical, and CEG is critical. So now we have the choice of shortening E or G because it's on both critical paths, or B and C together. So if we look back here, B is $100 and C is $100, but F is $100. Oh, sorry, F doesn't matter. It's E and G. E is $150, and we can shorten it, or we can shorten B and C. That's 200 plus 100, so it is cheaper to shorten E for $150, which shortens both of those critical paths. I'm not going to redraw the network. I am confident that it will work, but you can do it if you think you'd like to double check. But that will shorten the project by another day. And the question also was, what happens if we cannot shorten E at all? In that circumstance, we would compare G, which is $250, to doing B and C together, which would be $100. So if we can't shorten if we can't shorten E, we would shorten B and C because it's cheaper than G. So basically what we've done, we got the basic information here: tasks, predecessors, duration, crash costs, and maximum days. We got the questions. We drew the network with the appropriate precedence relationships: A, B, C, D, E, F, G. Did a pass from left to right to do earliest start, earliest finish. And then we did a pass from right to left, where we did latest finish, latest start. We looked for slack, and the paths that didn't have any slack was the critical path. We then identified that B was the cheapest to shorten first on that path, so we shortened B. It became 3. We did the pass from left to right again, the pass from right to left. We discovered we now had 2 critical paths. And from there, we determined that it would be cheaper to shorten E, which is on both critical paths, BEG, CEG, than it was to shorten B and C, which are on individual ones. And E was also cheaper than G. But the last question was, if we can't do E, then we could do G, which is 250, or B for 100 and C for 100. So B and C together are cheaper than G. So in that case, we would shorten B and C rather than G. So that's the basics of drawing a network diagram and crashing by 2 days. If you just follow those basic rules, draw the network, pass from left to right, pass from right to left, identify the critical path. If you get a question like this, I'm going to ask you to explicitly say how long it is, and then crash the cheapest tasks on the network. Watch if there is more than one critical path. Watch for those things that are on both or individually. That's the only place I can trick you. So good luck with this.